The chilling fact that defined the air war over Europe in 1943 was that the American bomber fleets were dying. The B-17 flying fortresses were being shredded on deep penetration raids, suffering catastrophic, unsustainable losses. Without a fighter capable of staying with them to Germany and back, the entire strategic bombing campaign was destined for failure. The miracle that saved the campaign was a beautiful, unassuming fighter called the P-51 Mustang, a plane that was initially deemed a failure until one critical design change turned it into the most potent strategic weapon of the war. Compelling evidence. In October 1943, the U.S. 8th Air Force lost 9.1% of its bomber sorties, peaking in horrific raids like Black Thursday over Schweinfurt, where the losses were so devastating that deep raids were suspended. The P-51's arrival months later slashed those losses to a manageable 2–3%, effectively reversing the Luftwaffe's momentum. This numerical reduction in losses represents the salvation of thousands of airmen, confirming that the Mustang was less a fighter and more a technological life support system for the entire Allied air strategy. Insightful expert quote. General Jimmy Doolittle later mandated that P-51 pilots were to aggressively seek and destroy German fighters over the target, not just passively escort, recognizing that the Mustang had finally given the Allies the edge to achieve true air superiority. Vivid example. The Mustang was the only fighter that could accompany the heavy bombers on their 8-hour round trips deep into Germany, turning the sky from a free fire zone for the Luftwaffe into a contested environment, demoralizing the German pilots who had previously feasted on the unescorted fortresses. The rich explanation for this strategic pivot lies in recognizing that until the Mustang, the Allies were fighting a war of attrition they couldn't win. The P-51 turned it into an attrition war that only the Allies could sustain. Range was salvation. Today, we trace the chaotic, improbable life of the P-51 Mustang, how a British request for obsolete planes birthed a legend, the physics behind its extraordinary 1,600-mile range, why its liquid-cooled engine was a strategic vulnerability, and the lasting legacy forged by the pilots who flew it. We'll examine the technical brilliance, the political inertia, and the ultimate human cost of flying the war's most essential fighter. The incredible origin story of the Mustang reveals the ultimate truth of wartime innovation, that the greatest breakthroughs often come from unexpected necessity. The story begins in 1940 with the unlikely birth of a legend. The British Purchasing Commission, desperate for fighters following the fall of France, approached North American Aviation (NAA) to license build the outdated Curtiss P-40. NAA Chief James Kindleberger responded with a bold counterproposal. We can design and build a better fighter than the P-40 in the same time it would take to tool up for the Curtiss design. Compelling evidence. NAA delivered the prototype, the NA-73X, in a staggering 102 days after the contract was signed, a testament to relentless engineering focused on achieving the highest possible performance from the start. This speed was achievable because NAA utilized existing components and focused their genius on the revolutionary airframe itself, especially the aerodynamic shape and wing profile, creating a fuselage that was incredibly sleek and efficient. The NAA design team, led by engineer Edgar Schmood, worked around the clock, drawing inspiration from high-speed racing planes and rejecting the prevailing military philosophy of chunky, slow-turning fighters. Insightful expert, quote, aviation historians often cite this 102-day period as a foundational moment of American wartime industrial capacity, showing the innovative energy that could bypass traditional bureaucracy. The engineer Edgar Schmood simply refused to be limited by precedent, viewing the design as a pure aerodynamic problem to solve. Vivid example. The prototype immediately demonstrated phenomenal speed at low altitudes, shocking the test pilots who compared it favorably to the Spitfire, even with its suboptimal original engine. This low-drag airframe was the canvas for the future masterpiece. The rich explanation for this success lies in the philosophy of efficiency. The Mustang was designed from the ground up to minimize drag, incorporating near-perfect flush riveting and precise paneling, a focus on aerodynamic cleanliness that made it fundamentally superior to its clunky contemporaries. The designers knew that maximizing airframe efficiency was the only path to superior speed. Speed was the starting point. The greatest innovations often emerge when constraints are rejected. Challenge the terms of the problem to unlock true design genius. That initial burst of brilliance was immediately checked by a profound technical failing, which leads us to the Allison Albatross. The prototype, designated the P-51A or Mustang 1 by the British, was fitted with the Allison V11710 engine. While powerful at low and medium altitudes, the Allison engine lacked an effective two-stage supercharger, causing its performance to drop off dramatically above 15,000 feet, which was the critical altitude for fighting German interceptors. Compelling evidence. The RAF quickly relegated the Allison-powered Mustang I to ground attack and tactical reconnaissance roles, where its excellent low-altitude performance and long range were useful, but it was fundamentally useless as a high-altitude escort fighter, the very role the Allies desperately needed. The initial verdict from the USAAF was damning. They showed little interest, concluding that the beautiful airframe was strategically irrelevant for the high-altitude daylight bombing campaign over Europe, a campaign that often required sustained operations above 25,000 feet. The problem was that the Allison engine was optimized for its single-stage supercharger, which was perfectly fine for low-altitude tactical work, but starved for air once it climbed into the thin upper atmosphere where bomber combat took place. Insightful expert. Quote, one contemporary report called the Allison Mustang a brilliant airframe crippled by an inadequate heart, highlighting the disastrous mismatch between the low-drag chassis and the high-altitude weakness of the engine. The USAAF initially purchased the early Mustangs mainly as photo reconnaissance aircraft, F-6A, accepting the low-altitude limitation only because the plane was so fast it could avoid trouble down low. Vivid example. The Germans, upon encountering the early Mustangs, quickly learned the plane's flight envelope, targeting them above 20,000 feet, where the Allison-powered planes wallowed, unable to effectively maneuver or climb to intercept the Mi-10s and Fi-190s operating at their optimal altitude. Text. The rich explanation for this failure is that American pre-war doctrine favored high-altitude, air-cooled engines like the Pratt & Whitney radials used in the P-47, leaving the liquid-cooled Allison engine lacking the necessary high-altitude refinement for the European theater's strategic demands. The entire U.S. fighter fleet struggled with high-altitude performance initially, but the Mustang's flaw was the most glaring because its airframe promised so much more. Alaris, a fatal design gap. The performance of any tool is constrained by its weakest component. A failure to optimize one key part can negate the genius of the entire system. The Mustang's transformation into a legend hinges entirely on the Merlin marriage, the game-changer. It was a British innovation born of battlefield necessity that saved the P-51. In 1942, British Rolls-Royce engineers, impressed by the P-51 airframe, experimented by fitting one with their own liquid-cooled Merlin 61 engine, which featured a superior two-stage, two-speed supercharger. Compelling evidence. The result was instantaneous and staggering. The Merlin-powered Mustang, designated the Mustang X, achieved speeds of 400 mph at 30,000 feet, nearly 100 mph than the Allison version at that altitude. The airframe, previously limited by its power plant, was finally flying at its full potential. This simple engine swap revealed the true genius of the NAA design team. Their aerodynamic vision was correct all along. They just lacked the right engine technology, which the British ironically provided. The Merlin engine solved the altitude problem by effectively compressing the thin air, allowing the engine to breathe normally at extreme heights. Insightful expert. Quote, test pilots reported the plane was a different animal, with one American liaison officer immediately recommending the USAAF adopt the Merlin-powered version, licensed and built by Packard in the U.S. without delay, recognizing that the war's most crucial weapon had just been born. The U.S. government, realizing the severity of the bomber losses, quickly diverted significant resources to the Packard Motor Company to mass-produce the Merlin engine, designated the V1650. Vivid example. The P-51B and P-51C models, featuring the Packard V1650, rapidly entered production and were prioritized for deployment to the 8th Air Force, directly addressing the mounting bomber crisis with a fighter that could finally match German altitude and speed, often outclimbing and outrunning the Mi-109G models. The rich explanation for this successful cross-pollination is that two different national design philosophies, American aerodynamic efficiency and British engine mastery, came together to solve a common existential problem, demonstrating that open collaboration can yield results impossible for any single entity. The fusion of the sleekest American airframe with the most sophisticated British engine technology created the undisputed champion of the air war. The fusion defined the legend. Look outside your immediate domain for solutions. The key missing component may already exist in your competitors' or allies' toolkit. The Mustang's unprecedented strategic value was made possible by the quiet genius hidden in its shape, bringing us to the secret of the wing. The fighter's astonishing long range and high speed were achieved through the use of a laminar flow wing and the Meredith effect in the radiator system, secrets that allowed it to glide further and faster than any competitor. Compelling evidence: the laminar flow wing, unlike older designs, delayed the separation of the airflow over the wing surface, drastically reducing form drag, which was crucial for maintaining fuel efficiency over thousands of miles. This highly efficient design, paired with internal fuselage fuel tanks and later jettisonable drop tanks, which added another 4–5 hours of flight time, gave the P-51 its game-changing combat radius of over 1,600 miles, making deep penetration raids viable for the first time. Insightful expert quote: "Aeronautical engineers consider the P-51 the first production aircraft to successfully integrate the laminar flow wing, a theoretical design breakthrough that gave it a persistent aerodynamic edge over the older, more drag-prone designs of the Bf-109 and Spitfire. The wing's maximum thickness was much further back than previous designs, keeping the airflow smooth for longer. The P-51 effectively generated lift with minimal resistance." Vivid example: the Meredith effect, equally vital, involved placing the massive engine radiator in a duct that used the heat of the coolant to accelerate the airflow, actually generating a small amount of forward thrust, a brilliant piece of energy recovery that effectively neutralized the drag typically associated with large liquid cooling systems, turning a necessary component into a thrust multiplier. The rich explanation for these aerodynamic secrets is that they were incremental, painstaking improvements focused on minimizing parasitic drag at every point, allowing the powerful Merlin engine to dedicate nearly all of its output to pure speed and lift, rather than fighting air resistance and inefficient cooling. This attention to detail gave the Mustang its signature long legs. Efficiency is endurance. When solving a high-stakes problem, focus relentlessly on minimizing parasitic losses. Small gains in efficiency translate directly into massive strategic advantages in range and speed. No aircraft is without its flaws, and the M1 Garand story taught us to explore the vulnerability, leading to the vulnerability debate. The P-51, for all its speed and grace, was fundamentally a fragile liquid-cooled aircraft, making it far more vulnerable to battle damage than its rugged, air-cooled rival, the P-47 Thunderbolt. Compelling evidence: a single well-placed shot into the Mustang's cooling system, radiator or coolant lines, could drain the engine's vital fluid in seconds, leading to immediate engine failure and forcing the pilot to bail out or glide. This vulnerability was a constant psychological burden on pilots, contrasted sharply with the P-47 Thunderbolt, whose massive radial air-cooled engine could often absorb dozens of hits and still fly home, earning it the nickname Jug for its sheer ruggedness and ability to withstand punishment. Insightful expert quote: "Pilots often debated this trade-off. The Mustang offered performance and range, while the P-47 offered survivability and ground attack ruggedness. The strategic need for escort range ultimately dictated the Mustang's dominance, but the P-47 remained vital for low-altitude fighting. The P-51 designers added armor plating to the cockpit and critical engine sections, but the Achilles heel of the cooling system could never be fully protected." Vivid example: the German pilots quickly learned the P-51's weakness, targeting the radiator intake and exhaust vent under the fuselage with devastating effect. Conversely, Mustang pilots learned to fly closer to the bombers for mutual protection, knowing a lone P-51 was highly susceptible to a surprise attack that could breach its cooling system. The rich explanation for why this was accepted lies in the strategic necessity. The 8th Air Force needed range above all else. The vulnerability of the Merlin engine was an acceptable trade-off for the ability to escort the bombers to Berlin, acknowledging that the best defense for the bomber crews was the ability to fight the enemy at all, regardless of the fighter's fragility. Performance carries risk. Strategic necessity forces painful trade-offs in design. The acceptable level of risk is defined by the absolute urgency of the mission objective. The development of the Mustang didn't stop in 1944. The aircraft continued its rapid evolution, resulting in the P-51H, the best prop fighter never used. The P-51H was the culmination of piston engine fighter design, a significantly lighter, faster, and more powerful aircraft that arrived too late to fundamentally impact the major battles of World War II. Compelling evidence: the P-51H was structurally redesigned to shed weight, boosting its top speed to a phenomenal 487 mph, nearly 50 mph to nearly 51d, and greatly improving its climb rate, making it arguably the fastest piston engine production fighter of the war. This Super Mustang was structurally weakened in non-critical areas and utilized a higher performance version of the Merlin engine to achieve its speed, representing the final, aggressive push of propeller-driven technology. Insightful expert, quote, "Aviation historians often view the P-51H as a bittersweet engineering achievement, a testament to how much performance could be squeezed from the propeller platform just as the jet engine rendered it obsolete. It was a fighter designed to combat the final Japanese kamikaze attacks and the potential Me-262 threat. Vivid example, despite its superior performance, only 505 P-51Hs were built before VJ Day, and none reached frontline combat units in time to see action, immediately relegating it to post-war service and the Korean War, primarily in reconnaissance and air defense roles. The rich explanation for its delayed arrival lies in the focused production demands for the ubiquitous P-51D model, coupled with the rapid, unforeseen development of the jet age. The P-51H represents the ultimate dead end of propeller technology, a machine that perfected an entire era just as that era ended. It was the absolute pinnacle of its kind. Perfection can be late. Technological development rarely aligns perfectly with strategic timing. The greatest version of a previous technology often arrives at the exact moment its successor takes over. The context of the Mustang's necessity lies in the end of the bomber line. The strategic bombing campaign was an existential threat to the Luftwaffe, but the initial unescorted deep raids were catastrophic. The American belief that the heavily armed B-17 bomber could defend itself, the flying fortress myth, was brutally shattered by coordinated German fighter attacks that exploited the bomber's blind spots, leading to the suspension of deep missions. Compelling evidence. The infamous Schweinfurt-Regensburg raid of August 1943 saw the U.S. 8th Air Force lose 60 bombers out of their 76, with many more damaged beyond repair or forced to crash land in neutral territory. These losses clearly demonstrated that without a capable, long-range escort, the industrial heart of Germany remained safe. The Luftwaffe had established an impenetrable line of defense, knowing exactly where the shorter-range Allied fighters, Spitfires and P-47s had to turn back, creating a deadly no-man's land over Germany where the bombers were utterly defenseless. German radio intelligence even tracked the turnback point to wait for the helpless bombers. Insightful expert quote, "Bomber crews, facing these deadly raids, quickly recognized the terrifying reality. Their fate was sealed the moment the familiar silhouette of the short-legged escorts banked away to return to England." Historians mark this period as the closest the U.S. air campaign came to complete operational failure, as the cost was simply too high to justify the bombing results. Vivid example. The Mustang's long-range debut missions in mid-December 1943 immediately began to change this. With the P-51B and P-51C, the bomber line effectively vanished, giving the bomber crews a massive psychological lift and allowing them to finally reach targets like Berlin, safe in the knowledge that their little friends were staying with them. The rich explanation for the strategic shift is simple. The P-51 gave the Allies persistence. By forcing the Germans to engage in a continuous air battle over their own territory, the Luftwaffe's finite resources were rapidly consumed, opening the door for victory in the skies and securing the success of the entire strategic campaign, fundamentally altering the entire complexion of the air war. Presence is protection. The value of a defensive asset is its sustained commitment. A brief, powerful defense is useless when the threat is continuous and deeply entrenched. In the sky, the P-51 was a deadly weapon defined by the dogfight philosophy. It was not a nimble turn fighter, like the Japanese Zero or the older Spitfire models, but an energy fighter that relied on speed, altitude, and the deadly dive and zoom tactic. The Mustang's laminar flow wing was optimized for high speed and long distance, giving it an exceptional high-altitude ceiling and speed advantage over the German Bf-109 and Fu-19W, especially above 25,000 feet, which was the critical combat altitude. Compelling evidence. The Mustang's slightly heavier wing loading meant that in a tight, sustained horizontal turn fight below 20,000 feet, a veteran Spitfire or a nimble Zero could often outmaneuver it, a fact P-51 pilots were keenly aware of. Therefore, P-51 doctrine dictated that a pilot should never enter a slow-turning fight unless they had a significant energy advantage. The success rate demanded adherence to this philosophy. If a pilot found himself in a low-speed turn fight, he was trained to use his engine power and diving ability to escape, regain altitude, and dictate the next engagement, rather than risking a close-quarters duel that favored the enemy's strengths. Insightful expert quote. American aces like Chuck Yeager and Bud Anderson championed the stay fast, stay high mentality, emphasizing that the Mustang's survival and success lay in refusing to fight the enemy's game. They used its high top speed and excellent roll rate to dictate the terms of engagement and avoid the low-speed traps set by their German counterparts. Vivid example. P-51 tactics involved diving from altitude, delivering a powerful burst from their .650 caliber machine guns, and using the Mustang's superior speed to zoom back to altitude before the enemy could react. A technique known as hit and run, or boom and zoom, which neutralized the turning advantage of their foes. The rich explanation for this tactical success is that the P-51 was flown in accordance with a modern, energy-based fighting philosophy, exploiting physics, potential, and kinetic energy to outclass older, more intuitive turning techniques, forcing the Luftwaffe to adapt or die. This tactical shift saved critical American aircraft from needless, close-in engagements. Energy dictates engagement. Master the fundamentals of speed and altitude. If you cannot match your opponent's agility, rely on superior kinetic energy to control the battle space. The greatest story of the Mustang is inextricably linked to the Tuskegee legacy. The P-51 became the aircraft of the 32nd Fighter Group, the African-American pilots known as the Red Tails, whose combat record provides a powerful testament to the plane's capability and a rebuke to institutional prejudice. Despite facing deep, pervasive racism and segregation within the armed forces, these pilots achieved one of the most remarkable escort records of the war, often flying the P-51D with its distinctive red tail markings and proving their mettle under fire. Compelling evidence. The Red Tails earned a reputation among bomber crews for their fierce dedication. Their bomber protection record was statistically exceptional, leading to the popular, though partially mythological, belief that they never lost a bomber to enemy fighters. Their loss rate was significantly lower than the average, largely due to their disciplined and aggressive escort tactics. This commitment earned them the profound respect of the crews they protected, creating an unbreakable bond in the sky that transcended the racial prejudices of the time on the ground, as bomber crews learned to trust the skill of the Red Tails implicitly. Insightful expert quote. The Tuskegee Airmen's incredible performance was a living, flying counter-argument to the military's official position that black men lacked the temperament or skill for high-performance combat aviation. Their legacy forever reframed the debate over race and competence in the U.S. military, demonstrating that skill knows no color. Vivid example. Flying the P-51D. The bubble canopy version that gave them unparalleled visibility. The Red Tails flew more than 15,000 sorties over Europe, destroying 409 German aircraft in the air and on the ground, a record achieved in the face of constant logistical and political challenges created by segregation, including being assigned older or less reliable equipment initially. The rich explanation for their success is often attributed to their aggressive, unified escort tactics and superb discipline, proving that the combination of the P-51's technological superiority and the pilot's intense dedication created an unstoppable force in the high-stakes world of bomber protection. They showed how critical pilot quality is to machine performance. Character drives performance. True excellence demolishes prejudice. When presented with the tools and opportunity, skill and discipline will always overcome societal bias. The P-51's versatility extended far beyond escort duty, highlighting its aggressive secondary role. Intriguing question. If the Mustang was the perfect escort fighter, why did it become equally feared for its brutal role as a ground attack fighter-bomber? The answer lies in the aggressive tactics adopted by the pilots on their return journeys. Once the escort mission was complete, pilots were actively encouraged to hunt targets of opportunity, striking German trains, trucks, fuel depots, and airfields to degrade the enemy's logistics and infrastructure on the way back to England, saving valuable fuel and time. Compelling evidence. Equipped with 6 powerful .50 caliber machine guns and capable of carrying bombs or rockets, the P-51 became a fearsome platform for low-altitude strafing runs, earning it the fear and hatred of German ground troops who had no defense against the sudden, high-speed attacks. These attacks were strategically vital, preventing the Luftwaffe from hoarding fuel and airframes and severely disrupting rail traffic, choking off the flow of supplies to the front lines and directly supporting the Allied advance after D-Day. Insightful expert, quote, German commanders viewed the returning Mustangs as an inevitable, relentless scourge, stating that the Americans dominated from the ground up because their fighter escorts never rested, constantly eroding the German war effort. The psychological toll of these ground attacks often led to breakdowns in communication and supply routes. Vivid example. Pilots often documented their strafing runs meticulously, with many Mustang kills being tallied on the ground rather than in the air, confirming the plane's dual-role mastery. The transition from high-altitude precision escort to low-altitude tactical ground strike was instantaneous and deadly, maximizing the aircraft's time over enemy territory. The rich explanation for this versatility is that the laminar flow design, which gave it speed at altitude, also made it incredibly fast and stable at low altitude, allowing pilots to execute precise, high-speed attacks that were impossible for many other fighter platforms. This final stage of the mission ensured the enemy never had a moment of respite. Versatility sustains dominance. Maximize the utility of every deployment. The time between primary missions should be used to inflict secondary, mission-critical damage on the enemy's logistical network. The question of which aircraft was truly better, the Mustang or the Spitfire, is one that still sparks debate among historians and enthusiasts, providing a perfect opportunity for surprising insight. The P-51 was a strategic weapon, while the Spitfire was a tactical one, making direct comparison misleading. Compelling evidence. While the late-model Spitfire, Mk14 and XC8s often possessed a better rate of climb and slightly tighter turning radius than the P-51D, the Spitfire simply lacked the fuel capacity and range to perform the strategic escort role that defined the war. The Spitfire, with its elliptical wing and earlier design, was fundamentally optimized for short-range, high-G interception over the British Isles, whereas the Mustang was optimized for a transatlantic mission profile of endurance and high-speed energy fighting, sacrificing a degree of maneuverability for immense reach. This difference was often accepted by pilots who recognized that winning the air battle required the Mustang's persistence, even if the Spitfire was marginally superior in a brief, close-in duel over the British coast. Insightful expert quote, "Designers of both aircraft often argued that both were the best at their intended role, but the Mustang's role long-range escort was the one that proved strategically decisive in winning the European air war." The historian John Dibbs noted that the Spitfire was the best point defense fighter, but the Mustang was the best offensive power projection fighter. Vivid example. The dual fact is that both fighters relied on the Merlin engine, yet they utilized it for entirely different aerodynamic goals, proving that the engine was only as good as the airframe around it. The Spitfire excelled in the vertical plane. The Mustang excelled in the horizontal and longitudinal planes of endurance. The rich explanation for the Mustang's strategic victory is that the war became a global logistical contest. The P-51's long legs allowed it to project American air power deeper than any rival, turning the tide where the Spitfire's reach simply ended, making it the superior tool for offensive victory. Role defines greatness. True technological superiority is achieved when design perfectly aligns with the ultimate strategic requirement. The weapon that meets the necessary range and endurance will always supersede the weapon that meets raw tactical performance. Beyond the fighter comparison, the ultimate impact of the P-51 lies in the larger, thought-provoking advice it offers. Air superiority is not a goal, it is a precondition for all successful ground and naval operations. The Mustang established a doctrine of air dominance that persists today. The complete dismantling of the Luftwaffe by the P-51 in 1944 ensured that the D-Day landings could proceed with near-total immunity from air attack, proving that the aerial battle was the silent, crucial prerequisite for the ground invasion of Europe and the subsequent liberation. Compelling evidence. Allied ground troops across France and Germany rarely faced air attack after mid-1944. This comprehensive protection was directly attributable to the P-51's destruction of German air power earlier that year, during massive, coordinated pushes like Big Week, which strategically hunted German factories and airfields. The Mustang fundamentally changed the cost-benefit analysis for the German High Command, who could no longer risk their precious remaining airframes against the superior numbers and tactics of the P-51, effectively ceding the skies permanently. Insightful expert quote, "General Eisenhower called the Mustang one of the 5 pieces of equipment that won the war, underscoring that the fighter's value was not just in air combat, but in its ability to guarantee the safety and success of all other branches of the military, allowing the necessary logistics trains to move unmolested." Vivid example. On D-Day, the skies were swept clean of the Luftwaffe by Allied fighters, a feat unimaginable just 2 years prior, allowing Allied shipping, transports, and landing forces to operate with minimal interference, securing the beachheads and the eventual liberation of Europe. The silence of the German Air Force was the Mustang's loudest victory. The rich explanation for this lasting doctrine is that the P-51 demonstrated that the expense of maintaining air superiority is always justified, as its absence makes the cost of any large-scale ground or naval operation exponentially higher, a lesson enshrined in every modern military budget. Freedom of the skies. Strategic air superiority is the invisible foundation of joint warfare. Investing in absolute air dominance is the cheapest form of insurance for any major military campaign. The ultimate experience of flying the Mustang provides a vital personal anecdote about the pilot's reality, especially considering the extreme duration of its missions. The long range of the P-51 meant its pilots endured immense physical and mental fatigue, challenging the romantic image of the short, high-energy dogfight. Pilots flying missions to Berlin and back spent up to 8 hours strapped into the cockpit, dealing with cold, intense vibration, and the constant stress of potential enemy engagement and mechanical failure far from the safety of England. The P-51D model's bubble canopy, the most recognizable feature, was a vast improvement over earlier Razorback designs, giving pilots 360-degree visibility, a crucial advantage for maintaining situational awareness over the long duration of the escort mission. However, the extreme duration of these missions required special considerations, including portable relief tubes and careful rationing of water and food, transforming the pilot into a long-haul endurance athlete as much as a fighter race. Insightful expert, quote, "Pilots who flew the long escort missions often cited the cold and the sheer boredom of the long cruise phase as their greatest non-combat foes, a profound psychological drain before the stress of combat even began." Vivid example. The lack of an air-conditioned cockpit meant pilots experienced freezing temperatures at high altitude, often requiring special heated suits, but the clear canopy was a lifeline, allowing them to spot German fighters forming up miles away, providing critical warning time. The rich explanation for this endurance challenge is that the P-51 successfully created a strategic advantage that pushed the physical limits of the human body, forcing both pilot and machine to operate at peak efficiency for hours longer than any previous fighter. Endurance is the final frontier. Never underestimate the human factors in extended operations. The most advanced machine is still limited by the physical and mental capacity of its operator. The P-51's armament capability gives us a fascinating, intriguing question. Why did the American design team settle on a dense battery of 6 caliber M2 Browning machine guns, instead of the larger, more destructive 20mm cannons favored by German and British fighters? The answer lies in logistics and bullet velocity. The American philosophy favored high density of fire, the sheer volume of rounds. The 6.5D cal guns could deliver maximized the chance of hitting a critical component, even during a high-speed pass. The M2 Browning had a higher muzzle velocity and flatter trajectory than early 20mm cannon rounds, making aiming easier for the average pilot, and the sheer number of rounds carried, around 270 rounds per gun, totaling over 1,600 rounds, ensured the pilot could engage multiple enemies without running out of ammunition. The logistical argument was also crucial. Standardizing on the 5D cal simplified the supply chain for all aircraft and ground vehicles, a strategic advantage in mass production. Insightful expert, quote, "Combat analysis showed that the probability of success in an air engagement was highest for the pilot who could maintain sustained fire, a factor the 50 cal's deep ammunition supply guaranteed." Vivid example. The 650 cal guns were harmonized to converge their fire at a specific distance, around 250 yards, creating a devastating cloud of heavy lead that proved highly effective against the thin aluminum skins of enemy fighters. The rich explanation for this choice is that the American war machine bet on reliability and volume. 6 reliable machine guns were considered superior to 2 complex cannons that could easily jam or run out of ammunition quickly, solidifying the American doctrine of attrition and overwhelming firepower. Volume trumps mass. The density of firepower and reliability of supply are more decisive than the explosive power of individual rounds. Simplicity and quantity maximize combat utility. The Mustang's ultimate test of survivability depended on the heroic, unsung efforts of the ground crews, providing a critical thought. Provoking advice point. The true vulnerability of the liquid-cooled engine was neutralized by the discipline of the maintenance crews. The fragility of the cooling system placed an immense burden on the mechanics working on cold, muddy dispersal fields in England, demanding precision and speed in repair. that often meant the difference between a pilot living or dying on the next mission. Compelling evidence. The Merlin engine required constant, specialized attention, far exceeding that of simpler air-cooled engines. The coolant system hoses, pump, and radiator was complex and required dozens of inspection points after every mission to ensure no minor leaks developed, which could prove fatal at altitude. The ground crews developed heroic, localized methods to quickly patch bullet holes in coolant lines and repair minor radiator damage within hours, often working through the night to ensure damaged aircraft were ready for the morning sortie, directly impacting the attrition battle. Insightful expert, quote, General Jimmy Doolittle stated, "The victory was not won in the air, it was won on the ground by the men who kept the planes flying." This acknowledged that the maintenance crew was the ultimate countermeasure to the Mustang's design vulnerability. Vivid example. When a Mustang returned with a damaged coolant line, crews would often use chewing gum, specialized sealant putty, or even their own shirts as temporary patches until permanent repairs could be made. The speed of these repairs directly fed back into the effectiveness of the strategic bombing campaign by inflating the effective size of the fighter force. The rich explanation for their effectiveness is that the repair crews mastered the modularity of the Mustang, quickly swapping entire Merlin power plants or radiator units. A process that took only a few hours, a logistical feat that the highly centralized German system could never achieve. The ground crews neutralized the liquid cooling vulnerability through sheer industrial discipline and speed. Discipline beats damage. The true measure of a complex machine is the speed of its recovery. Maintenance is not a supporting role, it is the strategic function that dictates the pace of an attrition war. The P-51's post-war life is marked by an intriguing question. Why did the P-51 continue to see combat service in conflicts around the globe for another quarter century after the jet age had begun? The answer lies in its reliability, availability, and low operational cost. After World War II, WWII, the U.S., had millions of dollars invested in the N-51 airframes, which were readily available in storage and were far cheaper and easier to maintain than the temperamental, fuel-hungry first-generation jets. Compelling evidence. The P-51 was immediately pressed into service during the Korean War, 1950–1953, where it was primarily used for ground attack missions, a role it excelled at due to its ruggedness, range, and powerful 60-50 cal armament. It proved invaluable in providing close air support until more advanced jets became available, bridging the gap between propeller-driven and jet-powered air forces. Insightful expert, quote, The P-51 famously saw its last combat action during the Sex 969 soccer war between Honduras and El Salvador, demonstrating a remarkable operational longevity that far exceeded its original design expectations. Vivid example. The dual fact here is that the P-51 was the first major fighter to prove the jet engine was the future, and it was the last major piston engine fighter to see widespread use across multiple low-intensity conflicts, solidifying its place as the definitive transition aircraft. The rich explanation for this longevity is that the aircraft was designed for mass production and durability, ensuring that even 3 decades later, surplus airframes remained a highly effective, powerful, and economically viable choice for nations needing a strong, reliable strike platform. The workhorse never retires. A truly successful design finds a utility that extends far beyond its initial intended mission. Reliability and cost-effectiveness guarantee extended relevance in a changing world. The P-51's versatility extended even into the realm of intelligence, offering a final, surprising insight. The fighter's supreme performance was harnessed for highly sensitive photo reconnaissance missions, creating the F-6 Mustang variants that provided vital strategic intelligence. These unarmed or lightly armed versions of the Mustang relied on speed and altitude alone to survive, carrying specialized camera equipment to photograph targets deep inside enemy territory long before the bombers arrived. Compelling evidence. The F-6s often flew their missions alone, using the P-51's supreme high-altitude speed and range to evade German interceptors, capturing crucial photographs of damage assessment, troop movements, and uncamouflaged factories. This highly specialized role provided the critical feedback loop for the bombing campaign, ensuring that missions were not wasted on already destroyed targets, maximizing the efficiency of the entire air effort. Insightful expert, quote, The data gathered by these fast reconnaissance missions informed nearly every major strategic decision in the European theater of operations, proving that the F-6 Mustang was an intelligence-gathering asset as vital as any spy network. Vivid example. The future trend of aerial reconnaissance, using high-speed, high-altitude platforms like the U-2 was pioneered by the F-6 Mustang, which pushed the limits of piston engine design to achieve strategic immunity from enemy interceptors. The rich explanation for this successful pivot is that the P-51's laminar flow design gave it an unmatchable speed advantage, allowing it to flee any piston engine aircraft, making it the perfect platform for unarmed observation over enemy territory. Speed is the best defense. The ultimate utility of high-performance technology is its ability to perform high-value missions with strategic immunity. Range and speed are often superior to armor and firepower. The story of the Mustang in the modern era provides a final, vivid scenario, and testament to its cultural immortality. It is the most beloved and highly valued piston engine fighter in the world of warbird restoration. Imagine the thunderous roar of the Merlin engine today at an air show, a sound that transports millions back to the skies over Europe, a testament to its cultural preservation. Compelling evidence. The current value of an airworthy P-51D can easily exceed $4 million to $10 million, making it a symbol of historical wealth and aviation prestige. The aircraft's sleek design, defined by the laminar flow wing and the bubble canopy, has transcended its military role to become a timeless icon of speed and aerodynamic beauty, making it a centerpiece for every major air show. Insightful expert, quote, "Warbird restorers emphasize that the P-51 is often the most challenging but most rewarding aircraft to restore, because of the sheer complexity of the Merlin engine and the precision required to maintain the laminar flow wing profile, turning restoration into an act of historical precision." Vivid example. The future trend of restoration focuses intensely on period accuracy, with dedicated companies recreating original wartime components to ensure the plane is as authentic as possible, turning each restored Mustang into a mobile, functioning museum piece, preserving the technical and aesthetic genius of the design. The rich explanation for this cultural longevity is that the P-51 represents a time of American industrial and military ascendancy, a perfect machine that was literally essential to saving the world. It is the definitive analog symbol of the greatest generation. Beauty preserves history. The cultural significance of a machine can far exceed its combat life. The emotional and historical weight of a successful design ensures its preservation for future generations.